Hi, my name is Brennan Block, and I'll be your tutor for the first segment in which we discuss synthetic substitution.
Hi, I'm Harris-Garcia, and I will be your tutor for the second segment in which we discuss graphing square root inequalities.
Before I start this tutorial, there are a few key terms you need to know in order to complete the problem correctly. The first key term is called synthetic substitution. Synthetic substitution is when synthetic division is used to evaluate a function. The second term you must know is PEMDAS, which is the order in which you simplify a problem. It stands for parentheses, exponents, multiplication, division, addition, and subtraction. Okay, with that in mind, let's get started. So the problem says use synthetic substitution to find g of 3 and g of negative 4 for the given function. And the function that is given is g of x equals x squared minus 8x plus 6. So here's how we do the first problem. So the first problem says to plug in 3 for all the x's. So everywhere that we saw x in the original problem, we plugged in a 3 here. So we plugged in the 3 where the x was here. Before I start this tutorial, there are a few key terms you need to know in order to complete the problem correctly. The first key term is called synthetic substitution. Synthetic substitution is when synthetic division is used to evaluate a function. The second term you must know is PEMDAS, which is the order in which you simplify a problem. It stands for parentheses, exponents, multiplication, division, addition, and subtraction. Okay, with that in mind, let's get started. So the problem says use synthetic substitution to find g of 3 and g of negative 4 for the given function. And the function that is given is g of x equals x squared minus 8x plus 6. So here's how we do the first problem. So the first problem says to plug in 3 for all the x's. So everywhere that we saw x in the original problem, we plugged in a 3 here. So we plugged in the 3 where the x was here. One more time. We plugged in 3 for everywhere that we saw an x, and then we simplified using PEMDAS. And the second part says to find g of negative 4 for the given function. So we do the same thing we did with the first one, except this time we're going to plug in negative 4 instead of 3 into all of the x's. So we plugged it in here, and we plugged it in here. Okay, so the first thing I did was went from left to right again, and negative 4 times negative 4 is 16, so I got the 16 here. And negative 8 times negative 4 is positive 32. So I got the 32 here. And then I drop down the 6. And then from here we just add. So 16 plus 32 equals 48. And then you drop down the 6 again. And then 48 plus 6 equals 54. So g of negative 4 equals 54. And g of 3 equals...
Okay, before I start this tutorial, there are a few things you should know. Square root functions and inequalities can be very difficult to graph because every function and inequality must provide a one-to-one relationship between x and y coordinates. Notice what happens if you represent x as 4 in the function y equals the square root of x. You end up with two values for the y-axis, including 2 and negative 2. Since this cancels out the function, as each x value can only correlate with a single y value, to solve and graph it, you must restrict the range to the interval 0 infinity. The only exception occurs when there is a negative coefficient in front of the square root, in which case the range becomes negative infinity 0. Step number 1. First you must isolate the y variable. Given the square root function y squared minus 3x equals 4, you would add 3x to both sides and then take the square root of both sides, getting y equals the square root of 3x plus 4. Given the inequality y squared minus 3x is greater than 4, we would follow the same steps and arrive at y is greater than the square root of 3x plus 4. Step number 2. Next, you need to determine the y-intercept by making x equals 0. Given the function y equals the square root of 3 times 0 plus 4, you would multiply 0 by 3 to get 0, add it to the 4, and then take the square root of the sum. Though the square root is in fact 2 and negative 2, you would only accept 2 because there is no negative coefficient. The interval for the range is 0, infinity. This means the y-intercept is 0, 2. Given the inequality, y is greater than the square root of 0 times 3 plus 4, you would arrive at the same y-intercept. Step number 3. Now you have to calculate the x-intercept by designating y is equal to 0. Given the function 0 is equal to the square root of 3x plus 4. You would square both sides to get 0 equals 3x plus 4, subtract 4 from both sides to get negative 4 equals 3x, and then divide 3 from both sides. This means the x-intercept is negative 4/3, 0, and if you were given the inequality, 0 is greater than the square root of 0 times x plus 4, or I'm sorry, 3x plus 4, you would arrive at the same solution. Step number 4. Acquire an additional point by designating an arbitrary or random value for x. If you were to designate x as 4 for the function y equals the square root of 3x plus 4, you would have y equals the square root of 4 times 3 plus 4. By multiplying 4 by 3, adding the product to 4, and taking the square root of the sum, you would arrive at 4. This gives you the arbitrary point 2, 4. Given the inequality y is greater than the square root of 2 plus 4, you would arrive at the same solution. Step number 5. Plot the x-intercept, y-intercept, and the arbitrary point, and then draw a curve that starts from the x-intercept, passes through both the y-intercept and the arbitrary point. You will need to use a dotted line if the symbol is greater than or less than, and a standard line if the symbol is greater than or equal to or less than or equal to. Step number 6. Shave everything above the inequality if the symbol is greater than or equal to, as shown here. Shade everything beneath the inequality if the symbol is less than or equal to, shown here. The shade shows that at any point within it is an acceptable solution for this square root inequality. Keep in mind to maintain the range. So, if you were given the inequality y is greater than the square root of 3x plus 4, which has a range of 0 to infinity, you would shade everything beneath the curve, or above the curve, until you hit the y-axis.
Thank you for watching our tutorial videos, and I hope you got something productive out of this.
Stay tuned for our next videos coming out soon. We're looking forward to it.